Hello everyone, welcome to Being Mathematician. In this video, we should discuss a very important topic which is so confusing to most of the students. Because this topic is not illustrated so much in books, videos, PDF, etc. So please keep your mind cool and concentrated on every second of this video. I will try to explain every why and how in this video, so stay with us till the end. So without any further delay, let's start the video. Let fx be the function where fx is a to the power x. Now if a is less than 0, then how do you explain this function? This is one of the important concepts in calculus. Now let's discuss this topic briefly. Let us assume that a is -5. However, you can choose any negative number instead of -5. But here we should proceed with -5. Therefore, we can write fx is equal to -5 whole to the power x. Now let's make a table with integral inputs of x. Now let x is 0, then y is -5 whole to the power 0, that will be 1. When x is 1, then -5 whole to the power 1 is -5. When x is -2, then y will be -5 whole to the power -2, and that must be 1 by 25. When x is 3, 5 whole to the power 3, and that will be -125. When x is -3, then y equal to -5 whole to the power -3, and that must be -1 by 125. If x is a fraction with even denominator, then y must be an imaginary number. We can explain with some inputs of x. When x equal to 3 by 4, then y equal to -5 whole to the power 3 by 4. Now it will be -5 whole to the power 1 by 2 whole to the power 3 by 2. Now this part can be written as √5 into I whole to the power 3 by 2, where I must be √1. We know this. Therefore, from this example, we can say y is not real. So, we can make another table when x is a fraction with odd denominator. Now let's make the table. When x is 1 by 3, then y must be minus 5 whole to the power 1 by 3, and that will be minus 1.70 approximately. When x is 1 by 5, then y must be minus 1.38. When x is 1 by 7, then y must be minus 5 whole to the power 1 by 7, and that will be minus 1.258. When x is 1 by 9, then y must be minus 1.196. So let's plot some points from both of the tables. Assuming that this is 0 and this is 1, this is 2, this is 3, and this will be minus 1, this will be minus 2, this will be minus 3, and here this is minus 1, this is minus 2, and positive y-axis, this is 1, this is 2. So now let's plot 0, 1, and this is the point. Now plot 1, minus 5, 1, minus 5, and assuming that this point is this, 1, minus 5. Now plot 2, 25. So 2 and 25 is so big. So assuming that this point 2, 25. Now let's plot minus 2, 1 by 25, and this is the point, assuming that minus 2, 1 by 25. Now let's plot 1 by 3, minus 1.70, and this point is here. See, it is not an exponential curve. If we plot the remaining points of the table, then we will see the same observation. I suggest you to do this alone. So the question is, why does this happen? Let's find out by proper analysis. If x is equal to minus 5 whole to the power x, now we can say y equal to minus 5 whole to the power x. By the definition of logarithm, we can say x equal to log y base minus 5. Applying the property of log, we know the property that is log a base b equal to log a by log b. Applying this property, we can write x equal to log y by log minus 5. Now let's find the value of log minus 5. We know that log of negative number is not defined in real number. So let's derive logarithm of a complex number. Let z equal to x plus iy, where I is root over minus 1 and x and y are the real number. So let's see this in complex plane, which is called ARGAND plane. In this system, y-axis is the imaginary axis and x-axis is the real axis. Now this point z can be plotted as here x comma y. So now this is imaginary part, this part, so this is y, and this is real part, this is x. So joining this line, and let this point is P and this is O and this is A. Now cos theta is base by hypotenuse. Here this is assuming that this is theta, so cos theta is x by OP. Now by Pythagoras theorem, OP is must be x square plus y square. So cos theta is x by root over x square plus y square. And sin theta is perpendicular by hypotenuse, that means AP by OP. AP is y and OP is root over x square plus y square. So sin theta is must be this. And we have to derive tan theta from the value of sin theta and cos theta. We know that tan theta is sin theta by cos theta and it must be y by x. So we should remember this data. So the complex number z can be expressed as square root of x square plus y square into cos theta plus I into square root of x square plus y square into sin theta. Now the common term is root over x square plus y square, so this into cos theta plus I sin theta. And root over x square plus y square means distance from the origin to the point is called modulus of z, and it can be expressed as mod z. So z can be written as mod z into cos theta plus I sin theta. Now, by Eulerian form, we can write z equal to mod z into e to the power I theta, since by Euler's form we can write e to the power I theta is cos theta plus I sin theta. Now we have to find the general value of logarithm of z. So general value of logarithm of z. So log z must be log of mod z into e to the power I into 2n pi plus theta. In general case, we have to add 2n pi with theta. So here we write 2n pi plus theta. Now, applying the property of log, we can say log mod z plus log e to the power I 2n pi plus theta. Now, the base of this logarithm is e, so must be, we can write I into 2n pi plus theta. Now, log of mod z means root over x square plus y square plus I into 2n pi. Now we can write tan inverse y by x in the place of theta, since tan theta is y by x. So by the property of log, it will be half into log x square plus y square plus I into 2n pi plus tan inverse y by x. So this is the general representation of logarithm of a complex number. So clearly minus 5 is a complex number. So let minus 5 equal to x plus iy. Now where minus 5 can be written as minus 5 plus I into 0 equal to x plus iy. Now comparing this, we get x equal to minus 5 and y equal to 0. That's why minus 5 is look like a real number, but really it is complex number in this video. So tan theta is equal to y by x, and this must be 0 by minus 5, and that is 0. So tan theta equal to 0, and the principal value of theta is must be pi. Since x is negative, therefore we can evaluate the value of log of minus 5 from this results. So now it is clearly half into log minus 5 whole square plus 0 square plus I into 2n pi plus pi. Now it must be log 5 plus I into 2n plus 1 into pi. Now we can put the value of log minus 5 in x equal to log y by log minus 5. Putting this value, we get x equal to log y divided by log 5 plus I into 2n plus 1 into pi. Now let's verify the integral table by this equation. Remember, the table was 0, 1, 1 minus 5, minus 2, 1 by 25, 3, minus 125, x equal to 0, then we can write 0 by log y divided by log 5 plus I into 2n plus 1 into pi. So here log y equal to 0, therefore y equal to e to the power 0 and it will be 1. So this result 0 and 1 is verified. Now putting x equal to 1, so 1 equal to log y divided by log 5 plus I into 2n plus 1 into pi. So log 5 plus I into 2n plus 1 into pi equal to log y. So y equal to e to the power log 5 plus I into 2n plus 1 into pi. Now by the rule of exponent we can write e to the power log 5 into e to the power I 2n plus 1 into pi. So e to the power log 5 base e must be 5, and this is by Euler'S property. We can write cos 2n plus 1 into pi plus sine I into sine 2n plus 1 into pi so y must be 5 into -1 plus 0, since the odd multiple of pi of cosine is -1 and odd multiple of pi of sine is 0. So this value is -1 and 0. So y equal to -5. So the point 1, -5 is verified. Now putting x equal to -2, so -2 equal to log y by log 5 I into 2n plus 1 into pi. So it will be -2 into log 5 plus I into -2 pi into 2n plus 1 equal to log y. So log 1 by 25 plus I into -2 pi into 2n plus 1. So y must be e to the power log 1 by 25 base e plus into e to the power minus I into -2 pi into 2n plus 1. Now y equal to 1 by 25 into cos of minus 2 pi into 2n plus 1 plus I into sine -2 pi into 2n plus 1. So y equal to 1 by 25 into this must be 1 and this must be 0. So y equal to 1 by 25. So the point -2, 1 by 25 is verified by this. So you can verify any values of x and y through this authentic formation of this function. Now let's derive the actual form of the function fx equal to a to the power x when a is negative. In the beginning we had x equal to log y by log a. When a is less than 0, now we have x equal to log y by log a plus I into 2n plus 1 into pi, and this is very authentic formation and it is proved. So from this we can write x into log a plus I into 2n plus 1 into pi x equal to log y. Now, log y is equal to log a to the power x plus I into 2n plus 1 into pi x. Therefore, y equal to e to the power log a to the power x base e into e to the power I 2n plus 1 into pi x. Therefore, by the property of logarithm, we have a to the power x into cos 2n plus 1 into pi x plus I into sine 2n plus 1 into pi x, and this comes by Euler'sian form. Now look at this part of this equation, that is sine 2n plus 1 into pi x is always 0 for any real x. So for this reason we get y is pure real number for any real x. So it is clear that the points on this function never be plotted in real Cartesian coordinate system. It should be plotted in ARGAND plane. I hope you have completely understood why in fx equal to a to the power x, a is always greater than 1 and a never be negative. If you think this information's really useful to you, then please like the video and please share your experience after watching this video. So stay with us and keep monitoring on this channel.